Today we're going to start in on this book, The Everyday Practice of Science by Frederick Grinnell. So hopefully you will either have or will be reading chapter 1 this week. And his main target, especially at the beginning of the book and sort of kind of throughout, is what he calls, and what I've been calling, the linear model of science. So this is a model of how science works that he wants to kind of enrich, complexify, to show us how it's a kind of limited picture of how scientific knowledge is actually generated. So chapter 1, he's mostly diagnosing why people think this way about science. So it's sort of, trying to unpack people's how we got this picture. But the picture is more or less the following. It's that there's a kind of, so two parts. One, that scientists are, as he says, objective, dispassionate observers of the world. That there is just a fact of the matter about what science tells us that doesn't involve things like interpretation or any kind of like subjective interest or anything like that. We talked a little bit about what is meant by objectivity last time. What I tried to show you was that that word has a whole bunch of really importantly different meanings, yeah? And that if you're going to try to deploy it in conversation, you should probably clarify which meaning that you mean. For example, in Grinnell's terms, it means something like value neutrality. So objectivity in Grinnell's sense is more or less, it doesn't depend on what you care about. Something is objective if your values don't play a role in kind of constituting it for you. You could mean something else. It could mean something stronger, like not coming from any particular point of view. That's disastrous. If that's what you mean by objectivity, then nobody's ever experienced anything objectively, because everything you experience comes from a point of view. You could mean something else, which is a sense in which Grinnell's eventually going to come around to tell us that he thinks that science can produce objective facts, which is something like, it's not value neutrality, but it's something is objective in this sense if it's shared amongst perspectives, right? It's not that it's not from a perspective, but that everybody's perspective will agree on it. So, for example, if I count the number of people in this room, I mean, it doesn't really matter what my hopes and dreams are. It doesn't matter what I think about political stuff. It doesn't really matter. Any of my values don't matter. And presumably everybody who counted us, if they are competent at counting, would count the same number of people. So it's not that I'm not doing that task from a perspective. Of course I am. It's just that everybody who does it will come up with the same answer. So agreement in some sense. So that's the sense in which he hopes science can produce at least somewhat objective facts upon which there are, from many different perspectives, and presumably perspectives with different value structures, will come up with the same answers. So we'll come up with the same, at least, picture of the debate. Okay, so that's sort of sophisticating, hopefully, a little bit about what he means by objectivity. The linear model of science, so on the assumption that scientists are objective in the sense of value neutral and dispassionate in the sense that they don't care how things work out, and that you can do science on those terms, the linear model says that science is a simple accumulation of knowledge. So every time you do an experiment according to this model, you just add to the pile of knowledge. The scientific process is, in this sense, a straight road. There's no turns, there's no twists, that kind of thing. So this model gets taught to practically all of us as the quote-unquote the scientific method. And there's a kind of caricature version of this that especially Grinnell, and I really appreciate his railing against science fairs, because this is the science fair model that they probably imposed on you in high school. And I don't know how you felt about that process, but I had serious qualms about every stage of this process when we did it. So come up with a question. I'm like, oh, what could I possibly ask that hasn't been answered before? Come up with a hypothesis. How do I come up with a hypothesis? Where does that come from? And what we'll see is that one of the really important ways in which values and perspectives play a role in constituting science is telling us what hypotheses are worth asking about, which hypotheses are worth testing, because testing always involves spending precious and finite time and energy and money, right? So which hypotheses are you going to spend those extremely finite resources on? That's a value question, and it's not a question. So notice that that question comes before you do any of the other stuff, all of the especially sciencey bits like doing experiments, making observations, and summarizing those experiments. Those are the kind of quintessentially scientific bits. Those are the bits that if you're going to go to the mat for some part of this process to be objective, those are the parts that you might think are objective. But the hypothesis drives the whole process, and where does that come from? And they didn't tell us anything. I don't know what your high school is like. They didn't say anything about that in my high school science fairs. So this kind of caricature version of the scientific method that treats it as a really straightforward process. Come up with a question, make a guess, see whether your guess was right, say whether your guess was right, the end. It's sold to us as the scientific method. And Grinnell thinks that this underwrites our picture. This is the kind of linear model of science that Grinnell wants to criticize, that he wants to help us sort of like see that it's a bit more complex than this. So we start from some hypothesis, we run an experiment, we get some data, and then we analyze it. They also didn't tell us anything about, I don't know, did they tell you anything about how to analyze data? I didn't get any of this. It was just add up the numbers or something like that. So as we get deeper into this stuff, and I don't think we'll talk about this today, but going forward, we'll talk a lot about step 5 here, where there are really a lot of choices that need to be made about how you're going to analyze data. Like, there are a huge number of decisions about how to treat data that you've been given, or you've produced through experiment. And those decisions are not things that, like, there's no, the temptation is to think that there is a fixed and mechanical rule that scientists apply. You've got a bunch of data, what do you do with it? And it's often sold to us as though that there is just one clear answer, and that scientists really at this stage just turn the crank and analyze the data. But that's not true at all. I mean, there are huge numbers of questions about, like, what are the appropriate statistical methods to apply to the data? Which bits of the data are outliers and therefore can be scrubbed out of the set? Which parts are core? You know, what does the data mean? All of that. There's no one single rule. And between sciences, those rules are different. They're treated differently in different sciences. So this apparently simple process, this apparently straightforward method, really hides a lot of the complexity of actual scientific practice, is Grinnell's claim anyway. So here's the model that he wants to replace that with. So this is sort of a cyclical model, a two-part cycle that he thinks more accurately describes the actual everyday practice of science. So there's two cycles here between, and the individual scientist is sort of moving in both of these cycles. There's the cycle of discovery, where the individual scientist, for example, goes to the world, develops an experiment, runs the experiment, makes notes on it, and then the world tells the individual scientist something. You know, you learn something by doing the actual empirical investigation, the actual observations and experiments and stuff like that. So the individual scientist is sort of informed by the world, and then once you've done an experiment, usually you don't just do an experiment and publish it. You do an experiment and it doesn't work, so you do a slightly different experiment. So you do another experiment and it works a little better or a little worse. And you do this cycle over and over again, developing kind of this relationship between you and the world. But then there's this whole other, so the entire science fair model of science is on this cycle, right? Actually, they don't even do it as a cycle. It's just once around. You do once around and now you've produced scientific knowledge. But that leaves out this whole other cycle between the individual scientist and a research community. So it's just not the case that you as individual scientists generate a result and then it just slips right into textbooks. There's a long, long process of, he calls the credibility cycle. So how do we take a result and decide that it's reliable. And that's not, I mean, if the scientific process, if the linear model was right, and the scientific process was just a set of mechanical rules that you can sort of blindly follow and produce reliable truth, we wouldn't need this credibility cycle. This wouldn't be an important part of the process. But the fact is that not all experimental results are equal. Not all experimental results show what people say they show. Not all experimental results, we don't always know what they show. So this cycle of credibility is, you know, where you go for having generated a research journal article. The cycle of credibility is how that gets taken up into the broader ways of thinking by the scientific community, that kind of thing. And of course, beyond that, so there's this cycle of the research community. Beyond that, there's another cycle where the research community communicates their beliefs to the wider world. So there's probably there's yet another circle way out here, but for the sake of simplicity, we're going to stick with these two. So this week we're dealing with just his broad picture. Next week we'll talk about the cycle of discovery. The week after that we'll talk about the cycle of credibility. That's kind of the plan for the next 3 weeks or so. Yeah? Okay. Okay, so talking about this sort of progress from, you know, you're at the bench doing an experiment to writing up a report to publishing the report to that report being taken up by the community to that sort of community belief being delivered to undergraduate aspiring scientists. That's a long, long road. And what he wants is to sort of highlight how rocky and complex that road actually is. I mean, it's just not a, and he wants to sort of diagnose, again, his main target in this first chapter is trying to diagnose why people think that this is such a, why people think science is as straightforward as they do. Like, and part of his analysis is we teach people science using textbooks. And textbooks are this extremely polished, finished product. Yeah? They are the absolute most shiny and clean version of the results of science. And they really misrepresent, well, they don't represent, they fail to represent the process by which it gets done. So people mistake the kind of, you know, when something is in a textbook, it's the kind of thing that the whole community agrees on. People don't put in textbook stuff that's controversial or very, very new. It takes a while to settle into the kind of belief structure of a scientific community to make it to where they're going to teach it to you in, you know, first year bio or whatever. So we start people on these extremely shiny, polished, finished products, and the mistake is to think that that finished product is what the process was like. Yeah? So he wants to take us through the process rather than the final product. He gives us an example. So we all know enough bio to know that this is true, right? So you got a bunch of DNA. That DNA is transcribed into messenger RNA, which is then fed into ribosomes that produces protein sequences. Yeah? This is a sort of, if that's not true, I don't know anything that's true. Yeah? Like this is one of the, like this is not really up for debate at this point in the scientific process, right? So like super reliable textbook fact. Yeah? And this is given to you, he says, in a biology textbook. He says, look, here you're just told DNA gets turned into RNA, gets turned into protein. And that's the story that we're given at the beginning. Yeah? We're just sort of given the end result. And thinking about objectivity here, it's like if anything's objectively true, that's objectively true. For whatever meaning of objectivity that you want, I don't know any way in which that depends on what you care about or your values. If you think that's wrong, you're wrong, right? Okay. Now that's what that tempts us into thinking is that the whole process was completely objective, completely dispassionate, and that it followed more or less the science fair model of science. Yeah? So he says this is either presented just as a raw fact, completely stripped of its historical context, or they might briefly mention the journal article where it was published. Right? So this was, of course, introduced to the scientific community. Before it got into textbooks, it was introduced probably at some conferences, but then officially in a journal article. So here's the journal article that was originally sort of produced this, sort of presented this fact. They won a Nobel Prize for this, so this is not like, this is pretty central stuff. This is the most central, important results in biochemistry probably for the last 100 years. Like, other than the discovery of the structure of DNA, I don't know of any more central, important scientific fact. Yeah? So this is the kind of thing that gets presented in journal articles. Journal articles are where they sort of present the results to the broader scientific community. What Grinnell says about the structure of it, so you've all, hands up if you've read a scientific journal article before. Most of you? Okay, good. So they've got a very kind of formulaic structure. You want them to have a formulaic structure. You want to be able to quickly, skim through it and find the bits that you're interested in, right? There's an abstract where they tell you basically what's going on, methods section, results, discussion, that kind of thing. So there's a kind of narrative built into the structure of a journal article, yeah? There's a step-by-step process where it looks like what they did is say, I've got a question. So in this particular journal article, they say, there's 3 basic hypotheses that we want to talk about in the relationship between DNA, messenger RNA, and proteins. We got 3 hypotheses. We want to figure out which one of them is true. What we're going to do is design a test that distinguishes between these 3 hypotheses. Here's our methods for doing that test. We did the test. Here's our results. Here's discussion conclusion. I'll take my Nobel Prize now. So that narrative is how almost all scientific journal articles are structured. All that I've read anyway, I've mostly been reading sort of biology, psychology stuff. Maybe it's different in fundamental physics or something like that, but this is the kind of stereotypical structure of a journal article. And notice that it fits really nicely that science fair model of science. Yeah? It looks exactly like the linear model. So this is a quote from the book. So you say the prevailing views start from a lit review, issues requiring further understanding, what are the active questions in this research area, testable new hypotheses, therefore experimental design, results, confirmation of one hypothesis, and falsification of others. It's just like the science fair model. Now, that's not how the experiments went. That's not what it was like and felt like in the lab while they were generating these results. So they didn't just sit down first with their hypotheses and say, okay, now we're going to do some experiments and figure out which of these is true. And we know that because we've heard, Grinnell gives us some nice quotes from the people who actually ran these experiments. So the journal article is rendered in a sort of dispassionate way. It's as though they don't care which of these hypotheses come out as true. They don't include any of the failed experiments, the experiments that didn't produce sensible results. They didn't include the calibration of the instruments. They didn't include any of that stuff. So here's a quote from one of the authors of that paper. Writing a paper, wrote Nobel laureate Francois Jacob, one of the authors of the Nature paper, is to substitute order for the disorder and agitation that animate life in the laboratory, to replace the real order of events and discoveries by what appears as the logical order, the one that should have been followed if the conclusions were known from the start. So that's the key. The journal article presents the structure of the experiment in the way that it would have looked if you knew from before you started what you were doing. Grinnell's going to sort of draw out from a whole bunch of different examples the ways in which confusion and accident and serendipity hugely structure the experimental process. Often people discover things that they weren't looking for. Often they fail to discover what they were looking for. And usually they don't, if they fail to discover anything at all, they don't publish that. So the null result is practically never published. So the journal article is written for really good reasons. There's really good reasons. I'm not saying that they should, you don't want a 60-page diary entries about how the experiment actually went. Yeah? You don't want like day 35, can't get the reagents to work. You know, the postdoc didn't show up today, so we had to delay for 4 more weeks. Like, you don't want that. You want an easily skimmable summary of the results of the thing. Yeah? So there's really good reasons why journal articles are structured the way they're structured, so that you can quickly extract the important bits for yourself. Yeah? That's why they have abstracts at the beginning of the journal article, so you really just have to read 1 paragraph to get the main bullet points. And if you care a lot about any of the details, then you know where to look and all that stuff. So the journal article itself is hugely cleaned up from the actual experimental process, but they don't tell you that in the journal article, right? They don't advertise all of the struggle and confusion and complexity that went into generating the thing that they publish. Yeah? So, and this is mostly aimed at diagnosing how people get sort of seduced into the linear model of science. Because at the textbook stage, they just present the facts. DNA, mRNA, protein. In the journal article, they present to you what it would have looked like if they had done everything sensibly, made no false starts, were never confused, and just did the exact right experiment to find the Nobel Prize winning results. Here's them describing, so this is again one of the authors of that Nature journal article that we're just talking about where they discovered this relationship. We were to do very long, arduous experiments, but nothing worked. We had tremendous technical problems. So we'll talk later about, I want to sort of linger here for a second. We'll talk later about demarcating between science and pseudoscience. And one of the most famous ways of doing this is by taking, if you have a hypothesis and the experiment doesn't agree with your hypothesis, then your hypothesis is falsified. So falsification is one of the most common ways of thinking about the difference between real science and fake science. And we're lucky that this research group did not give up the first time their experiment didn't work, did not produce the results that they were hoping for or expecting. They tried and tried and tried again until they made it work. And they absolutely did not go into it with no beliefs about what the result was going to be. So, full of energy and excitement, sure of the correctness of our hypothesis, we started our experiment over and over again, modifying it slightly, changing some technical detail. And if you're steeped in the linear model of science, that sounds like fraud, right? That sounds like they're cheating. What do you mean they're trying to get what do you mean they know ahead of time what the answer is? What do you mean they're running it over and over again until they get the answer that they were expecting? But that's how practically all science is actually done. That's the misleading part about the structure of a journal article, right? They write the journal article as though they had no opinion prior to starting the thing about how it was going to work out. And it's just purely the data spoke to them. You know, they came with blank minds to the world, and the world fed them information, and they're simply reporting what the world told them. That's not going to work. So we'll talk sort of this week and next week about the discovery process. That's simply not going to work as a method for doing science. You can't act like that and actually make discoveries. And this central biological principle was discovered by people who absolutely were not acting that way. And the idea that they are dispassionate, I mean, so eyes glued to the Geiger counter, our throats tight. We tracked each successive figure as it came to take its place in exactly the order we'd been expecting. As the last sample was counted, a double shout of joy shook the basement at Caltech, followed immediately by a wild double jig. They care a lot about these results. They are not emotionally indifferent. Yeah? And that sort of emotional connection to both their work, but also the hypothesis that they're trying to show is not incidental, Grinnell's going to argue. It's not a thing that you can just give up on or throw out and expect actually to produce better science. So I'm sure that's why he picked this example, because this is like, again, it's Nobel Prize winning science. This is the best we've got. It's a humongous discovery of central importance to all of biochemistry. And we have pretty detailed reports from the people themselves about what it was like to do the experiments, what they felt like while they were doing the experiments. It's this messy, chaotic, confusing mess. Sorry, mess was twice in that sentence, but you got it. And the orderliness of it all, the clarity, is kind of imposed in retrospect. You know? It's sort of, you make it clear after you've figured it out. After you've got the experimental result, then you begin to write up the journal article where you make it sound all very straightforward. And then you get it into it, if you're lucky, it gets into a textbook where it's made to sound like, this fact descended from heaven. DNA, mRNA, proteins, that's just an objective fact about the world that didn't involve any humans, didn't involve a human community, or anything like that. So I hope none of this makes you, I hope this makes you 0% less confident in the DNA, mRNA, protein connection. Yeah? Like, none of this is meant to make you skeptical about that end product of the process. Right? Like, again, if that's not true, I don't know anything at all, right? Like, that's just sort of like so central to everything that we know about living things. You'd have to throw out all of biology if that turns out to be false. But the process of getting there is very different. It looks very different than the final product. And that's Grinnell's point. Yeah? So the question is, how do we go from this chaotic, messy, confusing sort of complexity to that thing that I think everybody should agree on, which is the sort of textbook results that are extremely well verified and all that stuff. So, you know, this is just the, sorry, I think I've talked about all this. Like, really, the tinkering is left out, the failures and sidetracks are left out, and the hopes and desires of the people doing the research are left out. And again, you probably want it that way. Like, you don't want a one-page introduction of the scientist being like, you guys, this is the best thing that's ever happened to me. I love doing this experiment. It was tragedy and triumph. Like, you don't want it to be like a diary entry. You wanted the stripped-down version, but you also should be aware of what's being excluded from that report. So, once again, the textbook version of science is the most polished version. It's the part with all of that complexity stripped away. And just like with the journal articles, I hope it's obvious why they do that. Like, you don't want to have to learn the whole history of the science and all of the complex ins and outs in order to learn the basics of the science. You need to start somewhere fairly straightforward, fairly simple. But you don't want to be confused by that. You don't want to let that, you know, the difference between the finished product and the process for getting there should be kept very distinct in our minds. And that's really the sort of main point he's trying to make in these first chapters. Okay. So, with all that in mind, let's return to this notion of bias and objectivity, because I think that's a really serious concern in this discussion, where I'm trying to follow Grinnell, and Grinnell is trying to alert us to the ways in which interests and passions and values have a real role in the scientific process. And I think it's extremely natural to worry, if you're convinced of that now, that that compromises the process. And, wasn't this all supposed to be, isn't that somebody putting their thumb on the scales? Isn't that don't you worry that, I mean, don't you worry that a scientist passionate to prove their hypothesis correct is going to fall subject to things like confirmation bias? So we're aware of this result from psychology, right? That people systematically pay more attention to information that confirms their beliefs than disconfirms it. Yeah, confirmation bias, we know this? Heard of this? Okay, now you've heard of it. So people in general are we seem to be hardwired to really key in on that stuff that confirms our theories. Whether our theory is, the role of messenger RNA in protein synthesis, or my girlfriend's mad at me, like whatever your hypothesis is, that confirming evidence will be vivid for you, and disconfirming evidence will appear maybe not as important. It's not like you literally can't see it, but it's less vivid, it's less compelling, it seems less important to you than would be, strictly speaking, rational. So, I don't know, does this worry you? Yeah.
I just wanted to kind of say that I've actually seen quite a bit of actually like this kind of stuff.
Sure.
In a lot of the journal articles I read about, because I'm in archaeology and that kind of stuff.
Ah, interesting. Okay.
So like, yeah, you can definitely see sometimes a little bit of the bias. You can see how they're trying to correct it by doing like a blind test where they have like scientists, let's say they're trying to see how accurate this method of sexing with the skeleton is. So they're like, okay, sex the skeleton from this using this method. We'll see how many people get it correct or not when they know the. So that's their attempt at it.
Right.
But you can definitely see in archaeology for sure this thing where there's one example where there's this. It's a female skeleton, but it's buried as a prince would.
Right.
So, I don't know if this is boring all of you, but I find it immensely interesting. But then there's now discussions of whether or not it's a transgender person.
Right.
Or whether or not it's someone who was at that level for some reason was so highly regarded that they were buried like a prince.
Right.
And there's just this bias of not objectivity that just plays into everything, even though it's supposed to be science.
Right. So you find a lot of that in the journal article itself. So they're discussing potential biases. Yeah. They're discussing the reliability of their methods and that kind of thing. Yeah, interesting. So you see in the quote-unquote harder sciences, you see a lot less of that. You see very little of that in, for example, biochemical stuff. They just say, we did this test, we know it's reliable. They don't discuss the potential issues with their methodology. So in the more complex human sciences, maybe it's the case that people are more worried about that stuff and therefore more explicit about it. So again, this is nice to have like the illusion that there is one and only one scientific method is another thing that we should sort of take apart, because the ways that you write a journal article in archaeology is probably very different than fundamental physics. Yeah.
Well, I was just going to say that like the bias not only would be visible in the or would be concerning in the experiments and facts and stuff, but also in what gets chosen in these studies.
Right.
And I think Grinnell was talking about that in an article, and
Yep.
he was saying that since historically it's been white men who have been the ones performing science in scientific experiments, that they have been choosing and interpreting data from that kind of standpoint.
Right.
So, maybe not on purpose, but the experiments that they choose to perform are definitely influenced by that.
So this is the question of values in science, right? So this is once you crack open the linear model of science, these become serious live questions. Yeah, like, does it matter what the demographics of the scientists are? Is that influencing the way they're thinking about this stuff? And those become, I think, serious questions that we need to grapple with if we're going to preserve the idea that there's this sort of integrity of science, that it produces reliable results that we can build a society around. Yeah.
I'm sorry.
No, please. This is great.
To add to your point there about something that I know for sure, it's a lot of things in medicine.
Yeah.
I think medicine is objective and all of that, except a lot of these tests and that kind of stuff on white males.
Right.
And for example, we know for sure now that heart attacks are different in women.
Yep.
We don't
Yep.
know how different ethnicities or ancestry affect a lot of this kind of stuff. There's another thing where I came across it that, you know how with tick bites and that kind of stuff, you'll see that red circle?
Yep.
With people with a darker complexion, it doesn't actually show up as well.
Right. Right.
So that warning sign might actually not be noticed by doctors. And that
Right,
kind of
right,
stuff. So there's a lot of issues coming up with that.
Yeah. Yeah. So medicine is a funny one. Medicine, in some sense, is like engineering more than science. They're really just so depending on which part of medicine that you're interested in. Often they're really just so evidence-based medicine is where they say, I don't really care about the theory. Let's just measure what works, and we'll go with that. So it's a kind of more engineering style approach to it than a scientific approach. But you get that exactly those same kind of concerns. Psychology is really grappling with this, where for most of the 20th century, actually most of the 20th century psychology subjects were rats, but like once we got onto the human stuff, it was really you just round up the undergrads in your first year psych class. And as it turns out, undergrads in first year psych classes are not like every single human on the planet. Like there are important differences. For example, you grew up with the potential to get a university education. Like that's, I know for sure that you had some circumstances in your life made it possible for you to go to university. And that's not the same as everybody else for a bunch of important dimensions. So having this kind of biased sample, they call them weird subjects, Western, educated, industrialized, rich, democratic countries. And maybe people from weird samples aren't exactly the same as everybody else. So that kind of stuff becomes relevant when we start thinking through this stuff. Yeah. Yeah.
One thing to consider would be that there are more scientists in China than there are in the Western world. And so I think it would be potentially dangerous to think of science as something that the Western world is imposing on everyone else, because the parts of the world that are not the Western world have embraced the scientific ways of thinking, and
you've really jumped from the influence of values on science to the influence of science on values, in some sense. So this is a sort of big conversational. Hopefully this will come up in some detail, but maybe we don't want to get too deep into this. But I mean, I completely agree, and I've taught history of science, and if you look at the history of science, cultures like China and India produced huge amounts of the material that goes into the scientific revolution. So like China was way more mechanically, technologically advanced than the West for like millennia. They had repeating crossbows and gunpowder like while we were swinging poorly made swords at each other, right? So yes, I think the idea that science is a Western product is the result of a kind of scientific revolution narrative where the Western world erased the contributions of China, India, and the Arabic world. Like try doing math with Roman numerals, see how far you get, right? Like but that's kind of a separate issue from what we're worried about now. What I'm worried about now is modern science, and does it maintain its integrity? So once you crack open the linear model, you see the way that values, interests, passions, and all that stuff actually plays a role in the messy process of coming up with scientific truths. Can we still say that this process has the kind of integrity and reliability that the linear model made it seem like it did? Yeah.
Well, I just wanted to say, with all this in mind, if it turns out that, we are people and, we do science because we're people and not because we're robots, and it doesn't ask questions about itself, blah, blah, blah. Well, okay, isn't that kind of inevitable? Like, I don't think that it's reasonable to dissociate from who we are so much.
Sure.
We have this idea that we're just doing science for the sake of doing science because it's our duty to just kind of put the universe's order into words.
Sure.
Like, aren't we supposed to be doing it in some way so that at the end of the day it does benefit us or increase our understanding of the universe in a way that will benefit us?
Absolutely. I mean, yeah. So yes, very, very nice points. Yes. So like, doesn't it seem obvious that we're people, and of course we're doing it for people reasons and people ways, rather than robot reasons and robot ways. A thing that Grinnell wants to maintain, and this is the kind of here's the kicker here. Here's the stakes of this debate. Grinnell wants to maintain that science is special amongst the ways of generating knowledge, that is different than other ways of generating knowledge. So there's a whole bunch of ways to produce knowledge. You could meditate for 20 years in a cave and come out and say what you figured out. You could concoct a bitter brew of jungle herbs and talk to some spirits. You could take revealed texts from ancient times and interpret them as best you can. You can, do psychosomatic body work. Like, these are all historically ways people have claimed to have generated knowledge. You could rationally reflect on the principles of pure reason. Nobody wants to do that, but so science is supposed to be, or it's held up to be, in our culture at least, and by a lot of people, a special way of gaining knowledge, a way that's in some sense less dependent on. So like, some people meditate for 20 years and they realize that there's an essential godlike self at the core of their being, and some people meditate for 20 years and realize there's no such thing as a self, and that's all an illusion. Science is supposed to be the method of generating knowledge where it produces results that everybody should agree on. Any rational person, this is the way it's advertised. Any rational person should agree that these results are real and reliable. And if you get there, then you've got some sense of objectivity. Sorry, I saw one other hand. Sorry, you had your hand up. Yeah.
Well, it was kind of just to add to like point earlier about I think, and like I took a class kind of, and like we spoke about this a lot in our seminars, just about that, like now especially, like as long as, example medicine or whatever, like as long as the science is like benefiting us, a lot of people like won't challenge it and won't like question its integrity. So like, as long as it's beneficial to us, like why would we really care what the process was, kind of thing.
Right.
So I think that's like just to add to that point, that like a lot of times it doesn't get challenged anymore by like the common public, unless you're like maybe in sciences or something like that. Like you might think to like research it, question it, like why like how do they find this, like why are we following this?
Yeah.
Yeah.
Yeah, that sounds right. Which is a kind of cultural shift, actually. So, sorry, quickly, do you want to do a thing? Yeah.
How do you define rational?
By doing philosophy. That's the whole project.
But I mean, in this.
Let's do. There's whole classes on epistemology where we talk about that.
But when
you can come to my critical thinking class later today.
Okay.
Okay.
But like, when you're saying like a rational person would agree with science, like what do you mean
So,
by rational person?
Rationality is a success term. It means reasoning well. So whatever good reasoning is, and I don't claim to have a quick, easy answer to what good reasoning is. That's a matter of enormous debate.
Okay.
But that's the advertised picture. Okay. Okay. So there's a kind of. So here's Robert Merton giving what he thinks are the kind of ideal norms or values of science. Universalism, that is a sort of independence from values, value neutrality. Communism, not in the sense of seizing the means of production, but just in the sense that once you put out a scientific fact, it's not yours anymore, it's everybody's. Disinterestedness, and this is the one that we've sort of been working on. Scientists aren't supposed to care whether their hypotheses are confirmed or disconfirmed, despite the fact that they make a living by getting grants, by having confirmed hypotheses. And organized skepticism, that is, everything is regarded as up for debate. So this is the kind of ideal picture of how values are supposed to operate in science. And yeah, not so much. Like, in some sense, these are still the ideal, but the reality is starkly different. And we're working in reality, not in some fantasy world where everything is perfect. So, okay. this cultural moment, so it was interesting, just like, people don't question science. That is actually, so when I was a kid in the 1990s, there was actually a big movement to question the legitimacy of not all science, but science had taken on such titanic cultural proportions that people in the humanities saw it as their job to kind of knock it down a peg and question whether science deserved the authority that it had been given. They called this somewhat hyperbolically the science wars. So we'll talk a little bit about this. I think now my running hypothesis is now that if we don't figure out climate change, we're all going to die. People are much less excited about questioning science. Right, so when we study science through a social sciences lens, history, sociology, and that stuff, a quite different picture emerges of how it's structured. This is Thomas Kuhn's Structure of Scientific Revolutions. What we get is a picture of this second cycle that Grinnell's talking about, the credibility cycle, and how the credibility cycle affects which results are taken up and considered seriously and which aren't. Individuals don't do science, communities do science, and the dynamics of a community are going to inform the way science proceeds. So the type of community that you've got, and community structures are of course largely driven by values. For example, who gets the money? I mean, if you're ever in question about whether science has values in it, money is value. So who gets the money? How much do they get? Those are questions that sort of bring the values back into science. Sorry, I'm going to have to skim over this, but we'll come back to this in depth next time. So this is the 1990s science war, deconstructionist, postmodernist stuff that happened for about 10 years or something like that. So opening up your picture of science, cracking open the linear model and seeing the values operating inside tempted a lot of people to say that science is just a kind of social construction. That I think, I couldn't find the quote, but like that the knowledge in power is a lot like the might in might makes right. I think that's Foucault. I could not find the proper attribution for that. So that there's nothing more objective. So Grinnell wants to say science is in some sense special, and the objection from not as many people as is advertised, but some people wanted to say, no, science isn't special. It's another cultural practice just like any other cultural practice. So, you know, the fact that the knife goes on the right and the fork goes on the left, no, that's right, is about as objective as any scientific result. And I mean, yeah, we'll discuss this. Grinnell thinks not. Grinnell says, and I quote, "The postmodernists are wrong." It's not clear on who exactly. I always be skeptical about people talking about postmodernism, because unless they specifically say who they're talking about, it's a pretty vague term. But he distinguishes, and I'll end with this, he distinguishes three types of umpires. And he wants to ask us which type of umpire is science. One says, I call balls and strikes as they are. It's kind of naive, objectivist realism. Yeah? What I say is what it really is. The second says, I call them as I see them. I do my best to say accurately what's out there. And the third is, what I call them is what they become. And the accusation from the kind of science wars people is this is what science is like. Science is more like the third one. Grinnell wants us to convince us that it's not like the first one, it's the second one. He wants to convince us that science is like the second type of umpire, not the first and not the third. Okay, we're out of time. We'll talk more about this next time. Thanks, everyone.